Hi, welcome back to Imperium Learning. The topic of this video is going to be how to use your vector error correction model to do an ordinary least squares regression. Now, bear in mind that your vector error correction model is a system of equations where every variable that's included is the dependent variable in one of the equations. So just taking you back to my vector error correction model, you can see that I put in 5 variables, and obviously you can see here when you look down these columns, each of my 5 variables are dependent variables. Now the thing is, when I was doing my dissertation, I originally set out to investigate the macroeconomic determinants of UK house prices. So because of that, I was really most interested in finding out how variables like the money supply and credit and the interest rates and the unemployment rate impacted on house prices and not the other way around. So I think doing an OLS regression really gives us the opportunity to get to the bottom of to what extent these macroeconomic variables affect UK house prices. It also helps, by the way, it's also a convenient get out, because if you remember when I did the residual tests for my vector error correction model, let's take a look at the normality test. I don't think it suffers from serial correlation, but I think it suffered from residuals that weren't normally distributed. As you can see here, that these p-values are all way below 0.05. That's very concerning, because that shows that our vector error correction model isn't as well specified as it could be. So this as well offers a way of getting out of this issue. So going back, what we can do is we can estimate an OLS model, and hopefully the residuals for that model will it will pass all the residual tests. So how do we estimate an OLS regression using our vector error correction model? Well, the first thing we're going to do is we're going to click on proc, as you can see here. What we're going to do then is we're going to scroll down to make system, and then we're going to order our variables. We're going to order them by variable, like that. So as a result, we've now got our system of equations, and this is the way that you should be. This is the way they're set out for a least squares regression using the Eviews language. And all we have to do is highlight our chosen one. My topic of interest is the average house price, so I'm selecting that as the where I'm selecting the equation where the average house price is the dependent variable. I'm just going to copy that. I'm going to go to quick. I'm going to click on estimate equation, and then I'm going to paste that equation into the box. Now bear in mind as well, if you remember when I did these tests, my vector error correction model also suffers from heteroscedasticity. So what am I going to do? I'm actually going to change the covariance method and change it to the Newey West estimators. And the reason why is this will hopefully remove... I don't think my vector error correction model suffered from serial correlation, but it did suffer from heteroscedasticity. And bear in mind that the Newey West estimators are used to try and remove both serial correlation as well as heteroscedasticity from your model. So with that in mind, we click OK, and let me just close this actually. Delete that, yep. And we want to actually, let's just go back to my VECM for a second, and we want to scroll down, and let me just get this up like this. and just expand it, because we want to be comparing our OLS regression with our vector error correction model, in particular the relevant equation. So I'm going to be comparing my OLS regression with this particular column, because this is the relevant equation that I copied and pasted into the OLS estimation box. So with that in mind, how should we interpret and analyze this particular OLS regression? Well, first and foremost, we want to distinguish between variables that give us an insight into the long run information and variables that give us an insight into the short run information that exist between variables. And so bear in mind that the C1, the C2, the C3, all the way down to C14, these are in the exact same order, chronological order, as the order in the vector error correction model. So as you can see, C1 in particular, that's going to give us information about the long run relationships between UK house prices and other macroeconomic variables like the availability of credit and money supply and the interest rates and so on. All the others, however, with the exception of the constant, all of these are the lagged values. As you can see here, look at this. C2 is equal to D ln AHP minus 1. That means the first lag of the average house price. Minus 2, that means the second lag of average house price. So we can see that in the short run, we can see, and again, when I say short run, this is very similar to the results of the Granger causality test. Okay, so we can see that the first and second lags of average house prices are significant in explaining the variations of ln AHP in the current period, right? Because this equals C2 and that equals C3, C2, C3. But if we start looking at all the other variables, and we're looking again in our p-value column here, prob just means p-value, we can see that actually most of my p-values are way above 0.05, and bear in mind I'm ignoring C12, which is the constant. If we just take a look at this very quickly, if we scroll down, we can see that our constant is C12. Okay, C12, there are 14 in total. So with the exception of this, we can all see that the p-values are way above 0.05. And so what we would conclude then is we would conclude that these variables are not significant in the short run in explaining the variations in ln AHP. So now bear in mind, by the way, I can see that there's one variable which I believe is the second lagged value of my money supply. I think it's the second. Let's just check that. 1, 2, 3, 4, 5. Yeah, the second lag value of my money supply. So you can see here that that's C5. Okay, bear in mind I can see that I'm coming up to the 10-minute mark, so I'm going to just be wrapping up the video here, and in the second video I'll be finishing off how to interpret your results for your OLS regression, and then also showing you how to do your residual tests on your OLS model. Okay, bye now.